Hi guys, so today we're going to go over the derivative and the tangent line. So two interpretations of a derivative. The first one is the one we're going to address today, a function whose value at x is the slope of the tangent line to the graph of y equals f of x. So first I just want you to note the example I'm giving you. Since it's a linear function, meaning y equals mx plus b, technically you already know the slope. If you remember that m is the variable for slope, and it's always the coefficient of x. Whenever it's x to the first power, it's a linear function or a line. So for the first example, we already know the slope, so technically we already know the derivative. However, they're not always going to be linear functions, and we won't be able to see the slope or the derivative that easily. Also, there will be a little bit more algebra when they step it up to radical equations or radical functions or quadratic functions, so on and so forth. But I did want to start off with this example. And if you remember the difference quotient in pre-cal, we're just using the same formula. Just the only thing is that instead of h, they're using delta x. And I should note that it's the limit as delta x approaches 0. So it's just like the difference quotient, the limit as h approaches 0 of f of x plus h minus f of x all over h. They're using delta x instead of h. You can switch the variables if you want to. Sometimes they call x c. Just know that, these are interchangeable and it does happen. So, don't feel like it's a whole nother formula. It's not. So in this first example, I'm going to note down just the slope, that formula that we're using, so you can kind of see what we're doing. Now, in the first function, we're finding f of x plus delta x. So remember that the function given to us was f of x equals 2x minus 3. Since I am finding f of x plus delta x, I am using the same function they gave me. I'm just replacing the x with x plus delta x. Make sure you always substitute in parentheses. So I'm going to bring down the 2, and again, instead of x, I'm going to replace it with x plus delta x, and then bring down the minus 3 that I haven't used at all. So same function, all I did was replace the x with x plus delta x. So from here, to simplify, I'm going to distribute the 2, which is why it's important to always substitute in parentheses, because distributing may not happen properly without it. So this would give me 2x plus 2 delta x minus 3. So I'm going to replace this first function with 2x plus 2 delta x minus 3. And then it says minus f of x. So remember, we're given f of x. It's 2x minus 3. F of x equals 2x minus 3. The only thing is make sure that you substitute again in parentheses, because otherwise that minus sign in front of f of x won't be distributed properly. Everything else I'm going to bring down. And then it's just about simplifying the numerator first. So if I were to distribute this, and I'm just going to kind of modify it just because I'm running out of room here. If I were to distribute this negative, this would give me negative 2x plus 3. So I'm going to modify it here. So this would give me negative 2x and then plus 3 after I distribute that negative sign. So from here, I'm combining like terms. So I have 2x and I have negative 2x. Adds up to 0. I have negative 3 and I have positive 3. Negative 3 plus 3 is also 0. So what I'm left with is the limit as delta x approaches 0 of 2 delta x over delta x. Now, since there are no plus or minus signs, there's nothing to be factored out, and I will show you what I mean in the next example. So I can just divide it out. Delta x and delta x divide out, leaving you with 2. Usually after you divide out, you would use direct substitution, but since there's no delta x to substitute, you're done, which means that the slope is a constant value. So no matter what the x and y value are that they ask for the slope at what given point, it's always going to be 2, which we know because the slope of a line is going to be 2 at all times. The rise over run is 2 over 1. All right, guys, I hope this helps.